Air quality matters inside our buildings and out. And I believe we already have many of the tools we need to make a difference. The conversations we have and how we share this knowledge is the key to our success. I'm Simon Jones, and this is episode 33 of the Air Quality Matters podcast. Coming up, a conversation with Iain Walker. Joining me from California, he is the leader of the residential buildings team at Lawrence Berkeley National Labs. An ASHRAE fellow, leader and developer on standards and technical committees for ASHRAE, ASTM, RESNET, IEC, and the IEA, and other national and international organisations. He's a board member of the IEA Annex 5 Air Infiltration and Ventilation Centre for the US, and much more besides. He also happens to be one of the reasons I started this podcast. He's one of my favourite people to talk to in this industry. You come away energised, usually a little wiser, and almost always having spent a couple of hours talking about something completely different from what you expected. But importantly, wishing more people could have had a chance to listen. And that was one of the triggers for the Air Quality Matters podcast. We discussed the intersection of sustainability and air quality, got massively diverted onto cooker hoods, and probably need to do a part 2 at some point. Thanks for listening as always. Do check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Iain Walker.
It's one thing to have like a really good idea or to write a good standard or to have, something wonderful you could put in a house. But unless people actually do it, it doesn't really change anything, right? So one of the key questions we're trying to ask these days is, how do we get to scale with anything, whether it's air quality or decarbonization? How do you get this into like as many homes as possible? And some of that is about, communication and understanding what it is that motivates people. So some of our more recent work we've been working with, we have colleagues, other national labs at PNNL, for example. Our colleague Chrissy Antonopoulos there has been working with us on those sort of things, where we do things like survey hundreds and hundreds of people to ask them questions about their perspectives on things like air quality and decarbonization and what might make them change their minds, what they like, what they don't like, what they've heard, what they haven't heard, what would help them to make a decision, and sort of get into that. I'll call it human behavior aspect of things. So we are not behaviorists, right? But as people who are trying to figure out, what R&D questions should we answer as researchers, it's kind of important to understand, are we asking questions that are the questions that people making decisions, in our case, individual homeowners, right? Are those the questions they're asking or not? Because if we ask the wrong questions from an R&D perspective, it won't be helpful, right? We'll have answers to questions people are not asking. And similarly, when people ask us questions, we'll be going, I don't know, we didn't study that, so we can't help you. So there's this sort of interesting aspect about how we relate our work as researchers to how would that get implemented, right? And sometimes that is our work is to advise policy, or it's technical background for changes to standards where that's like where we're changing requirements. What must you do, say in a building code or building regulation, right? But some of these new ideas are a little more subtle in that it's trying to figure out how would you present something or persuade people to do something else in their homes, right? Rather than saying you must do it because the law says so. When you're building a new home, how are you going to change the home you're currently in? Right? Persuade people that might be a reasonable thing to do, Anyway, that's sort of like a very interesting area. We're just getting started on that, to be honest. And of course, behavioral scientists have been all over these sort of issues for a long time, but we haven't really had this situation where, we've had sort of effectively the technology R&D people, which is, what we do at National Labs, talking to those people as well. Anyway, that's sort of, if there's any other sort of big area that's just starting out, I would say that is sort of a very interesting
I
thing to
think
be
it's
thinking about.
indicative of this coming together of disciplines we're seeing more and more in the sector, because
Mhm.
public health has been involved with behavioral scientists for years. So, like, they
Right.
understand that relationship, but there's much less of that in the built environment engineering end of things, understanding the behavioral side of it. And that's a
Yeah.
part of the conversations I've been having a lot recently on the podcast, actually, is that trying to
Okay.
understand more about the behavioral science and the citizen science of this stuff. There was a great quote from Douglas Booker, I've just did the podcast this week with him, and it's that saying, uh, "No research about us without us," which I thought was a
I like
brilliant
that. Yeah.
concept. That we shouldn't be
Yeah.
doing anything about us without us being part of that citizen science piece. And then I had a really interesting guy called Dan on, who's a UX UI expert, user experience expert.
Mhm.
And he
Yeah.
was saying a lot of this stuff is actually just product development and marketing. A lot of the principles you're trying to understand within the built environment is just about understanding needs and framing
Yeah,
and
absolutely.
language.
Yeah, yeah.
Like, a lot of the answers we're looking for is buried within what happens in the commercial sector the whole time, that whole UX UI process, and what it is
Mhm.
to the built environment. So I think that whole area is fascinating. And the one I'm really digging into at the minute, which is a discipline in of its own, is communicating risk. How do we
Yes.
communicate the risk of something that's so esoteric and often long term to the general public or to individuals in a way that can stimulate purchasing decisions or behavior change or habit change? And you know we'll probably talk at length about cooking later on, and cooker hoods. We're not trying to get people to stop cooking in their homes, but we're almost certainly going to require a behavior change or a habit change from people to start using equipment they just don't use at the moment, like cooker hoods. How do we frame that
Indeed.
risk for people effectively? I think that whole area of communication and framing is fascinating, absolutely fascinating.
Yeah, yeah, I agree, and it sort of permeates all the work that we do, and I think that even research funders in the field that I work in are becoming more aware of that. And I'll just give you one quick example. We're just about to start a brand new um, bit of work for the California Energy Commission, where there's been a lot of work done to try and persuade people to electrify some of the end uses of their homes here in California. The challenge is not that you can't buy a great heat pump to heat your house or make hot water. That's kind of trivial. You just go get it, right? That's not the hard part. And those machines, they're pretty good, actually. They're pretty efficient. I mean, they really do what they say they're going to do. The challenge is that it's not easy for an individual homeowner or occupant to figure out what to do, like who to call and how do I make decisions about, do I do it all at once? Do I do electrify everything in my house all at once, or should I spread it out? And what sort of questions should I be asking the electrician or the contractor who's doing the work? Because this is a new thing and people don't know. So anyway, the work that we're going to do for the Energy Commission is to produce a free tool that'll be free to use for anybody who wants to use it, that guides people through the process, tries to answer their questions, and sort of as just to the point you were making, This isn't necessarily risk analysis per se, but it's about people to provide the information people need to make decisions and help them and make the process easy. I think making it easy is the key thing. Something is difficult, no matter how great it is, people won't do it.
Yeah.
And the challenge we have, at least in the US, is that you get sort of standards of practice. You know, what do your local contractors do when they do something in a home? Well, if that's what they do, everyone you call is going to give you the same answer.
Yeah.
Which is do what we've always done and not change. So people need help with the process that isn't going to be easy for them.
Big changes
And
nearly always require trade-offs. It doesn't mean that on balance it's a negative trade-off or a positive trade-off, but significant changes in the way we heat or electrify or manage our built environment nearly always require some kind of trade-off. We've seen that particularly in this part of the world with heat pumps, that one of the big obstacles has been stored hot water. You know, if you're on gas or oil and you've got instantaneous hot water through combination boilers, switching to heat pumps and having stored hot water for the first time in your life can be a trade-off. You know, you've always been used to turning on a tap and having as much hot water as you need. And all of a sudden you're faced for the first time in your life with running out of hot water if the teenagers have got in before you. Now, if you've grown up with stored hot water, that's not new to you. It's not a problem. You wouldn't see it as a trade-off at all. But that's a really good example of by not understanding and having the language and the framing for people of heat pumps has presented real problems. And people will absorb one trade-off, maybe two, but if there's two or three or four, all of a sudden, once negative sentiment starts to creep in to some of these changes, they can be really difficult to persuade people, you know. And
I think you're right. And I mentioned earlier this work we've done where we've surveyed people to figure out what it is they think are going to be issues. And frankly, some of the key answers that we might see as barriers or whatever are ones where it seems obvious, but if you're a technology developer, it's not the sort of questions you ask. So I'll give you a few examples. When we talk to people about home electrification, they ask questions like, well, who's going to install this new thing? And how do I maintain it? What do I have to do? Who's going to maintain it? When it goes wrong, who do I call? And there's all these like super practical things where for the house they have now, they know the answers to all those questions. But we're telling them, oh, we're going to change, put in these new things. And now they don't have answers to those questions. They don't know who to call. And we get there's obviously the classic questions that are always asked in these things, like, are my bills going to go up or down? Right, which is always always the really hard one, trying to answer because often the engineering analyses that get done are, say, population-wide to inform a policy. So you say, well, if we do this in 1 million homes on average, everybody's going to save £5, €5, $5 a month, whatever the number is. But it doesn't mean every single home does. And the challenge is trying to, you mentioned risk earlier. This is a risk analysis, right? We know that some homes, well, guess what? It might be the case that actually your bill's going to go up that €5 or $5 or whatever, or £5 a month. And trying to be upfront with people about that, because you don't want to mislead people, but do it in a way where it doesn't panic people. They're like, oh, you can put people very easy with very small numbers, right? People are looking for a reason to not do something. So those sort of questions, we have to have ready answers for. And I think we're sort of realizing that it's not enough to say, well, just buy the thing and install it. That is not satisfactory. That's not going to work. Right, we have to be able to answer these other questions.
And you're doing quite a bit of this work at the moment. I'd be interested to get your perspective on how you see that intersection of air quality and decarbonisation, because they do go hand in hand. There are both co-benefits of electrifying the home. There's co-benefits of making buildings more airtight and sealing them from outdoor pollution or having more control of ventilation. But equally, there are challenges with underventilating buildings or unintended consequences of certain things. Are you seeing quite a bit of crossover between those two disciplines with the stuff that you're doing?
The classic case is that for many years we've been trying to build not just homes, but almost all buildings in a way that they're more airtight. And usually we mechanically ventilate them with fans in some way, but it's controlled, right? We have controlled ventilation, which really has brought down the amount of heating and cooling we have to do quite significantly. So great thing for energy efficiency and all of that. And in fact, when we're looking at taking homes and electrifying them, one of the challenges is, particularly for older homes, is that they are not very airtight. They're still quite leaky. And so one of the things that we're trying to get people to do is, let's say you want to replace a furnace or a boiler with a heat pump, is to do things like, well, maybe we should put a little bit of effort into improving the building by things like reducing how leaky it is and maybe insulating it if it's not insulated, or adding insulation, particularly I think in attic spaces, So, and why does that matter? Well, that's effectively reducing the load. It's reducing the amount of heating you have to do in the winter and the cooling in the summer, which means you can purchase a smaller piece of new equipment. And that saves you money up front because a smaller capacity, a smaller device, it just simply costs less money. It also makes it easier to install because it's often physically smaller, right? It's easier to find the space to do it. So there's sort of a link there with, what you invest in reducing the need to heat and cool a home gets reflected in some money that you save when you're installing the new equipment. And there's some balancing to be done there, right? So I think there's sort of, there's that connection simply from what engineers would call the building loads, like how much heating and cooling do you need to do to be comfortable in this space, all gets connected. And one more issue there that is a kind of a new thing. We've talked about energy efficiency in buildings. It became a big thing in the late 70s with the energy crisis. And we've talked about energy efficiency for a long time. And I think one of the new things we're very interested in is what you might call it power efficiency, or a phrase we're using is low power electrification. And what I'm talking about there is it's not just how much energy you use to heat and cool your home and make hot water, for example. We're also talking about what is the peak power requirement. And if you can keep that low, that has a lot of implications. Firstly, if you keep it low enough, you won't have to upgrade the electric system for your home, and you won't have to change the wires that connect your home to the street, which again saves money and it saves time and it just makes it easier to do. The savings there are tremendous. And honestly, much bigger savings than the idea I talked about a few minutes ago about if you buy a smaller heat pump because the load's lower. Reducing the peak power so you don't have to replace all the electric infrastructure in your home is just such a huge savings up front. And also looking to the future, we're trying to do electrification in a way that I will say is kind to the electric grid. By that, I mean, we don't want to really massively increase the load on the grid because that will cost us a lot of money in the future. If we have to replace all the wires in the country, or add a whole second set of wires, or build more power plants, that takes a long time. So there's big time delays, which means that will delay any of the things we want to do. There's already places in California that are denying people where they're like, I'm sorry, our electric system is at capacity. You cannot electrify your home. That's already happening. And so we want to avoid that. Plus the future costs, at least in the US system where we have privatized electricity, anything they invest in new wires, new transformers, new substations, new generating plant, That just automatically gets passed on to the ratepayers, and you will pay more for that electricity in the future. So there's massive future cost savings as well if we can limit the power. I know we got off on a tangent here away from air quality, but these things are all connected, right? You do this one thing about air tightening, and it has all these subsequent consequences that are very interesting in terms of the influence they have from a policy perspective, and also for individual homeowners, and even thinking sort of bigger picture about, do we have the capacity in the electric system in our countries to actually do all this electrification?
Yeah, they're fabulously cyclical conversations, because, you know, you introduce embodied carbon and making nuanced decisions on the type of products or materials that you're putting into the home, or conversations that are happening around my circle at the moment about whether fabric first is the right choice, or whether they call it fabric fifth, where actually the trouble is with changing the fabric of the built environment is that requires stakeholders to go along a process that can take some time and isn't moving fast enough objectively. So one of the advantages of heat pumps is you just get people you mandate that when a boiler breaks, it's replaced with the heat pump. You're not bringing consumer decisions into that process. You're decarbonizing the heating of homes without having to get people into long retrofit programs and decision-making processes. It's even better decarbonize the actual grid itself, and then you remove the consumer completely from the process. So like, it's an incredibly complex web of like what moves the needle here when it comes to decarbonization. And smack bang in the middle of that is a conversation now about having it focused purely on energy and not on healthy, sustainable buildings, doesn't bring in a lot of KPIs and metrics that could be quite valuable for people to make decisions on decarbonizing their homes. Because that's been one of the challenges, is you ask people that have had work done to a decent level in their homes, very rarely is the energy the thing that they talk about. It's the comfort and health and well-being. And you lose that conversation track if you don't have health and well-being and sustainability in the center of the conversation piece. Is that something you equally find where you are? And also, just for my sense, when we're talking about homes, instinctually, are you talking about Californian homes? Or because when we talk about the States, obviously it's quite a spectrum in North America of environments. For context, like when I'm just discussing homes and decarbonisation with you, Iain, are we talking about your part of the world?
Oh, I thought you were going to say more broadly across the world, which is an even wider question. So to answer you directly, that the work that I do it has a strong US or North American, if you will, focus. But frankly, a lot of the things you've just mentioned, I think they're universal truths. This idea that people don't really care what heats their home, so long as their home is comfortable and so long as it's affordable. Right? That's the two things people want. They want to be comfortable in an affordable way. The actual device that does the heating, frankly, nobody cares. Right? And similarly for hot water. Right? People want hot water to come out of the tap when they turn the tap, and do that in an affordable way. And what makes it hot, who cares, right? You're providing a service, right? That's the key thing. And that, for engineers who are like all about what does this piece of equipment do, that's sort of that's not how they think, right? It's a different way of thinking about the world. But you're 100% correct. It's universal all over the world. It's true that's how people think about these things. But in terms of types of housing, we're looking at all kinds of homes. And in fact, in the US, for anything where, like I'm a researcher, right? Our funding agencies are very much emphasizing that we are definitely going to be addressing, say, multifamily homes, particularly low income. Similarly, we have something called a HUD manufactured home, which is a trailer home, if you will. I can't remember what the UK terminology is, but in theory, you could move in. It could be on wheels. But as a matter of fact, the only time the wheels are on it is when it came from the factory and it's put into place. You have, there's like holiday camps we can go that are full of these things in the UK. So I think you're familiar with that sort of housing. Well, in the US, there's a lot more of it. And again, it's very inexpensive, right? Often the people living there are on lower incomes, and it's a challenge for them. It's not going to work if we electrify their homes and double their heating bill. It's not going to work for them because they don't have the money, right? So a lot of what we're doing is focused on making sure that what we're doing is affordable and affordable across a whole spectrum of the population, right? It's not good enough to just look at, say, single family homes or owner occupied. We've also got renting is just the biggest challenge when we talk about what are we going to do about adding ventilation homes from an indoor air quality perspective. Traditionally, that has always been challenging. And now when we talk about heating and cooling and hot water and changing all those things, if you rent your home, whether it's an apartment or a flat or a house, you often don't have any control over that whatsoever. And so there's this disconnect between who lives in the space and who would potentially benefit and who owns the property and can make the decisions. Traditionally, the issue has been in energy efficiency programs where the person who would benefit with the lower electric bills or the lower fossil fuel bills would be the occupant, but the person who would pay would be the person who owned the building. And that classic disconnect has been debated to death forever, and it's very, very hard to overcome. And now we sort of have a similar thing when we're talking about replacing heating and hot water systems with heat pumps is who benefits, who pays. And frankly, a big concern in the US is sort of the reverse of the old problem, where let's say your landlord does put a heat pump in, but the bills go up. The tenant had no say in that decision, and yet now they have to pay more. Or the classic issue, if you have a multifamily building with central hot water or central heating or central ventilation, central systems, where those are in effect included in the rent. There's not a separate bill for those. But at least in the US, a lot of multifamily buildings, the electricity for each unit is billed separately. So if we now go to an in-unit heat pump, the occupants, the renters, are now paying for the heat where they didn't pay for it before. And of course, in theory, that means their rent goes down, right? Because they don't have to pay to run the central system. But in effect, of course, that doesn't happen. And we'll need legislation to deal with that will effectively force the building owners to reduce the rent because the central systems are not operating anymore, and it's all on the individual occupants. Anyway, dealing with rental properties is very, very hard in these things we do. And whether it's installing ventilation systems, going from central ventilation to ventilation individual units, or whether it's doing heating, cooling, and hot water, right? So you asked about the housing types. It's all of them, and some are more challenging than others. And also, it's not just the architectural differences, if you will, and the construction differences. These ideas about who owns what, how we help renters is hugely challenging. And if I had an answer, I would tell you, but I don't.
I mean, it's difficult enough when what you're doing is quite well understood and measurable. Energy outcome is quite definable in a lot of cases because there's a bill at the end of it. But when you talk about split incentives and air quality, boy, does it get complex quickly. Now,
absolutely,
there is a complexity to comfort and energy for sure. We've seen particularly in the less well thought out programs all that you've done is made buildings more affordable to heat. It hasn't actually brought bills down. You've just increased the average temperature or reduced the average temperature, depending on where in the world you are. But with air quality, it's much more nuanced and difficult. And I think that's where you've been at the forefront for quite a while, Iain, is that trying to understand where we are with the measurability of air quality. And I think we're even seeing organizations like ASHRAE now focusing in more and more on metrics of air quality as part of standards, aren't we? That it's that move to saying, okay, well, how do we define air quality if we're going to start measuring it and defining outcomes? We're going to have to start framing this in a slightly different way to likelihood of discomfort type metrics.
Yeah, I mean, I think there's sort of three core issues around air quality, and some of it is historical. You talked earlier about cooking. Well, historically, when people first moved into caves, one of the big problems was those caves filled with smoke when you tried to cook. And there are definitely old caves that have vents in them to vent out the cooking. Then when people started to live in huts and so on, they all had an opening at the top to smoke out. Or they did it, I mean, just amazing, I guess we would call it clever engineering these days, about using different construction materials for the roofing that would actually effectively allow the smoke out, but wouldn't let rain or snow in. I mean, very, very mostly using reeds and things like that. But this idea of venting our cooking has been around forever, and certainly we sort of lost that thread somehow. Certainly in the US and somewhat in the UK, ovens for the longest time had a flue pipe that came out of them and vented to outside. We did not vent into the kitchen for the cook and everyone to breathe. I live in an old house. When I remodeled the kitchen, right there in the wall was the circular thing where the original cooking device vented to outside. But somehow people got persuaded, we don't need to do that. And we stopped venting. Well, we got to vent, right? We should never have stopped venting our kitchens. That was a mistake, right? And I don't want to. I'll use cooking as an example, but it's kind of true of other indoor air quality things too. There's three components going on. The three components are that moisture is a big one, right? We've all had the experience of cooking in the winter with cold windows and moisture running down them and so on. And so controlling moisture has always been an issue for cooking and for air quality in general, right? Venting away the moisture. Human beings, we're emitting moisture all the time. The things we do like cooking and cleaning and everything emits moisture. We've got to have moisture control, right? That's been an issue for ventilation air quality forever. We don't want water running down our windows and rotting out our window frames. We don't want mold growing because we've got high humidity in dwellings. Okay? So moisture is the classic one. And then there's sort of this idea about what we might call perceived air quality, which is, it's kind of aligned with comfort. It's about how do people feel about a space? Do they feel it's stuffy or whatever? And that's a little more subtle, but this was sort of studied quasi-experimentally quite a few years ago. And it is the basis of things like ventilation standards, honestly, is this idea that you need to get rid of I'll loosely say human bioeffluents. I won't get into any more detail on that, but this idea about stuffiness is things that it's almost a subconscious thing where a place, the air just does not feel right. And people have different reactions to that, different levels and so on. And so you need to ventilate for perceived air quality. And then I think the one that we often talk about the most is indoor air quality and health, right? Which is what is in the air that might make you more or less healthy. I mean, the classic contaminants there are things like particles that you can breathe, oxides of nitrogen, ozone. There's a whole host of things. But the ones that come out on top are things like particles, oxides of nitrogen. Formaldehyde is another one that quite a few of your listeners may have heard of. And those have health impacts. Some are known better than others, right? But at least for the leading ones, there's been enough medical studies done that we know it's not just correlation. We actually know the chemical processes happening in people's bodies and why it's important. And large scale epidemiology has been done. We know enough about those health impacts that in effect you could monetize them. And in the US anyway, the Environmental Protection Agency and others have tried to develop frameworks for doing exactly that, where you can say, well, if you have this level of particles, it's this much of a health hazard. We can convert that into things like overpopulation. How many more hospital visits is that? You convert that into dollars and so on. And there is a movement that's gathering strength that says healthcare providers, rather than any other entity, might be the ones who are most interested in improving air quality in homes. Because particularly if you have a publicly owned healthcare system where everybody pays in and benefits, if you can do things like halve the number of people going to the emergency room with asthma attacks, that can just simply, you can monetize that and say, well, we're going to save so many £1 million, euros, or dollars a year because we have this program that improves air quality in low-income neighborhoods, for example, because we put in better ventilation, or we put better, in the US, we do a lot of heating and cooling by blowing air around, right? So we can filter relatively easier. I know it's harder in Europe where you heat with hot water. You'd have some standalone filtration system, but it's not beyond the wit of man to do that, right? You can have subsidies from things because we can monetize the health impacts, right? And this has been done for a long time with outdoor air quality, actually. It's why we have outdoor air quality standards, honestly, is there was this idea that we could monetize, or we could, it sounds macabre, but we can count the number of deaths, right? If we have this level of NO2 or this level of particles in outdoor air, for example, we can say that's so many excess deaths a year. I'm sure your listeners are familiar with that sort of terminology and seen it before. But it allows us to make decisions, or at least you mentioned risk analysis earlier, Sam. You can say, well, if we do this, the risk is that happens. If we do this or don't do that, we get some other outcome. And you can evaluate things that way. But that's why we have outdoor air quality standards. Certainly in the US, and particularly California kind of led this, about trying to limit things like particles and NO2 in the ambient. The challenge has been we don't have what I would call the equivalent for indoor air. Now, you can make the argument that, well, a lot of what's in the indoor air came from outside, right? I think particularly things like particles and NO2, unless you have fuel combustion in your home. If you're living in an all-electric home, it all comes from outside. And, we've done the research communities and lots of experiments to determine things like the average indoor concentration of outdoor particles is like half. And so we kind of know this from measuring thousands of homes. So again, we can sort of evaluate the impact of outdoor air quality on our health. We don't have indoor air quality standards, and I think we might get there one day, but it does provide us a challenge, right? Because it's not always easy to change building codes and standards and regulations. There are people who don't want to change, and they can rightly say, you can't use these numbers because they are for outdoor air, and now we're talking about indoor air quality. And we have these circular arguments, that the standards committees I sit on, we have exactly these discussions, right? About can you actually legitimately use a number the World Health Organization developed for outdoor air, indoors, so on and so forth. It's just quite challenging, but at the same time, it does allow us to do as you were suggesting, which was you can do a risk analysis. So you can say, how much will everybody benefit if we do this or do that in homes, whether that's ventilating or air cleaning or So circulating back to where 5 minutes ago, if you vent your cooking is a great source of things that you don't want to always be breathing. Now, I understand there's a trade-off here, right? I mean, if you're frying a nice steak or something in garlic butter, I mean, it smells fantastic, and it's part of a culinary experience, and I would never deny anybody that. But you also have to understand that when you fry that steak in garlic butter, there's a huge plume of contaminants that come off that long-term can have health impacts. It just is true, right? And so it's a trade-off, it's a balance, it's a risk analysis. And I would argue that you should definitely not change what you cook, but you should turn on your cooker hood when you do it. And one of the great benefits of being human is that in terms of odor, the things that matter for cooking, you don't need very much of it in the air to sense it. We have a great nonlinear thing stuck in our nasal cavities that is fantastic at smelling the delicious thing you're cooking, even though you might have vented 90% of it to outside, right? So I believe you can get almost all the health benefit without detracting significantly from the cooking experience by turning on your cooker hood. I think that there are other challenges with things like kitchen venting around why is it so noisy, right? When we survey people, when we go into we study this in homes. We're always doing measurements in homes all the time. And we're always asking people, why did you not turn on your cooker? Because we monitor people's kitchens to see when they're cooking, do they vent? Sometimes they do, sometimes they don't. Mostly not, to be honest with you. And the number one reason is people don't think it's necessary. People do not connect this idea that cooking might actually put contaminants in the air. And second is the fan is just too noisy. And you know what? People are not wrong.
Yeah.
They are noisy, right? So we're working with manufacturers and rating organizations to try and figure out, are there ways to redesign the hoods and give them a new rating, which will make them quieter at the operating speeds we like and things like that. So there could be some technological advances there, but it's a real issue, right? It gets back to the sort of provision of service, if you will. Everybody will be like, yeah, please vent my kitchen, but I still need to be able to have a normal conversation in the kitchen while I'm doing that, right? I don't have to be shouting over the bracket of a fan.
I'll have you back to the podcast in a minute. I just wanted to briefly talk to you about 21 Degrees, a partner of this podcast. Formerly the Green Building Store, they were founded in 1995 by 3 exceptional building professionals. The company grew out of their frustration with the poor availability of ecological building products. I've known them for years as the go-to company in the UK for end-to-end design-led MVHR systems. We spend the majority of our time in our homes, so they should be the best they can be, comfortable and healthy to live in, with exceptional efficiency. In fact, life-changing homes. At 21 Degrees, you won't find a more trustworthy, straight-talking, passionate about what they do, and approachable group of people. I speak a lot about the performance gap on this podcast and what we can achieve if we value ventilation highly enough. 21 Degrees embodies that sentiment for me. So if you're building a home, looking to install ventilation, or need to talk to experts in the field, I can't recommend them highly enough. Links are in the show notes at airqualitymatters.net, and you can Google We Are 21 Degrees. Now, back to the podcast. That's interesting. So you saying those conversations are starting to happen with industry now about realigning what the value of that product is? Because like cooker hoods, there's only 2 decision-making processes with cooker hoods as far as I can see. One is aesthetical. Is it a metal one for my modern kitchen, or is it a wooden one for my country kitchen type decisions? Or if you're a developer, what's the cheapest piece of shite I can put in that's humanly possible? Because the quality of the cooker hood will have no impact on how much I can sell this kitchen or home for. Therefore, why would I invest any money whatsoever in providing something decent? And the net result out of that has been I have never seen a specification for a cooker hood because nobody cares and has ever asked for one, quite frankly. The only thing that they have to do is comply with whatever the national regulations are for the flow rates for cooker hoods, if that country has one. But there's no interest in the acoustics or the capture efficiency or the performance of that system. And as such, they end up being horrible, rattly metal tin boxes with the cheapest fan that you could possibly buy going into it. So as far as low-hanging fruit goes for product development, there must be an awful lot there. At the very high end, I see the Bosches and the Miele's and some of the fancy cookers starting to have a bit of demand control, that they'll automatically come on when there's cooking, and they'll talk about them being quiet, that they'll have some acoustic ratings. But you have to be prepared to spend 400, 500, 600 euros on a cooker hood in order to get that, which most people aren't. You know, that I think personally, and I imagine I'm probably pushing on an open door with you, kitchen ventilation is going to be one of the most fascinating areas of public health development in indoor air quality over the next decade or so, because there's so much focus on the harm that PM and cooking pollutants can do. There's so much evidence building for that. And the products are starting from such a low base that there's so much room for innovation and upselling and development that it could be a really fascinating area for people that are prepared to get on with it and do it and get ahead. Can you imagine, brilliant capture hood efficiency and demand control, that comes on when detects certain types of cooking even, and, is able to do that silently and with power. You could have some really fantastic products potentially,
Yeah. You basically provide a great synopsis of sort of the state of the art, right? Yeah. And you're right. I think that there is increased attention being paid to ventilating of kitchens, and for good reason, right? It is actually sort of one of the principles of good air quality is what we call source control. By that we mean remove the contaminant at its source before it mixes in the house, because once it's mixed in the house, it gets even harder to get rid of. You have to move a lot more air. So if you're cooking, having a hood over the cooker is absolutely the way to go. It's the same, I draw the analogy with formaldehyde. One of the reasons we measure much lower formaldehyde in homes than we did historically is not because we're doing a fantastic job of ventilating away formaldehyde. It's because the products we bring into our homes have had the formaldehyde content regulated to be much lower than it used to be. So there's just less of it getting emitted.
Yeah.
Now, you can't really do that with cooking, right? I get it back to, frying the steak again. You got to fry the steak. There isn't like a way to have low emitting steak. That's not a thing, right? But we can vent it better. And you asked me if, about ongoing work in this area. And I'm currently a member of there's a US national standard. It's called ASHRAE Standard 62.2 for ventilation of homes. And it has a specific section in it that actually talks about venting kitchens and cooker hoods and so on. And as you mentioned, it says there's a minimum airflow. You can obviously go higher, but there is a minimum airflow requirement. That's the current specification. But it also includes some noise requirements, both for whole dwelling ventilation and for kitchen ventilation. And we're in the process of looking at those to see, do products actually meet this? Do they meet it at that minimum airflow? Or can you get them to meet it at a higher airflow that might be better ventilating your kitchen? And so there's actually a sort of a subgroup of people involved in that standard, working together with manufacturers of cooker hoods and rating and certifying agencies to think about, do we need new test methods? Can we adopt test methods we've already got and use them better? Can we change how certification works? And an example of that is if you do a sound rating at that minimum airflow, which is 100 cubic feet per minute or about 50 liters a second, it's not too hard to be quiet at a low airflow for a fan and a duct system. But let's say you went to 2 or 3 times that airflow in the same device. It gets noisy. And that's a challenge because what we know from a lot of experimental work, both in the laboratory and in homes, is probably not surprisingly, the higher the airflow, the better you exhaust those contaminants from kitchens. But, and you raised this point, Simon, is if you have everything have the same airflow, different hoods do a better job of capturing the pollutants and throwing them away outside. This idea of what you call capture efficiency is exactly that, right? For any given airflow, what fraction of the contaminants are removed from cooking, what fraction go into the kitchen and the rest of the house. We call that the capture efficiency. So, as you said, ideally what you want is a high capture efficiency, so low contaminant levels in the house. It should be at as low an airflow as possible in order to be quiet, because the movement of air is what causes the noise. And that's a challenge. But we have measured quite a lot of different cooker hoods, and there are definitely cooker hoods that work much better than others based on things like their geometry, how much, just their physical size, honestly, like how much of the cooktop is covered. What we've learned is that it's much more challenging to get rid of the contaminants when you cook on the front burners and the front heating elements compared to the back ones, for obvious reasons. Here I'm talking about, a cooktop that's mounted against a wall or something. We've got a wall at the back of it. But as a cook, it's much more awkward to cook on those back burners than the front ones, so people don't do it, right? So we've got this point where you have a cooker hood that might have great capture if you're cooking on the back burners, but you don't use them, and so it doesn't work so well. So the way you get around that is you have to physically have a larger cooker hood. Then you have compromises about, well, if you put a big cooker hood, you don't want people banging their foreheads on the hood, right? This is very practical, right? So you have to change the height of the cooker hood. And something else that we know, again, experimentally, and probably makes, from a common sense point of view, this makes sense also, is that if you move further and further away from the cooktop, mount it higher and higher and higher, you're losing capture efficiency again, right? Because the plume of contaminants gets to escape, and so there's a lot of factors going on. But the bottom line is we're working with manufacturers and rating organizations, as I said, to try and develop better cooker hoods that do a really good job of ventilating your kitchen at lower airflows. So using less fan power, if you care about that, it's quieter and so on. And also working with the rating agencies, because you mentioned marketing. A key thing for manufacturers is that if they make a change to a product, but it's not reflected in the rating, it's hard for them to get credit, right? Because there's a disconnect. People just generally don't trust manufacturers of anything, to be honest, right? It's all marketing. But if you say something is rated in this way, to a standardized way, that is something that is kind of a bit more believable.
So do you think it will move more towards kind of like a CADR rating for cooker hoods, that there's rather than a flow rate necessarily, there's an amount of pollutants that are emitted in a test laboratory, and you're judged on the capture efficiency and the noise levels in order to do that, and you can get ratings. So there'll be a standardized way of capturing that number for people. So the onus on development and product development will be to get better and better capture efficiency at lower and lower fan speeds, at quieter and quieter sound levels, and encourage that innovation. So there's a metric that people can be judged by.
Yeah, absolutely. Because without that, it's very difficult for product manufacturers to figure out, what is the best plan for us to get there. And there is actually a test method in the US anyway. It's promulgated by ASTM, the American Society for Testing Materials, that us researchers have been using, product manufacturers have been using to evaluate their product, and it's a laboratory test. It's not, you don't go to people's houses, so it's a very standardized test procedure where everything has a fixed geometry, and we fix the temperatures of hot emitter plates and all that sort of thing. So it's the idea is that you want something that's kind of repeatable, right? So it's the same every time, standardized testing. And we're currently working to make that an international standard with colleagues from Asia and Europe. And we're sort of partway through that process. I would guess like a year from now, there'll be an international standard available for this that will be both acceptable and applicable to Europe, Asia, and the rest of the world. If we can get everybody testing the same way, that's a huge advantage, specific really for manufacturers, right? If they know, I build this product, I test it once, I can sell it in any market in the world because we've all agreed this is the test method that we like, that we're going to say this is how we're going to rate things. That's a huge bonus for them, because what they don't want is a patchwork where every country has its own test and their products have to be tested 30 times, because that's really costly and time consuming. So we're trying to
end up
avoid
the scenario
that
we've had with air cleaners, where nobody really knows what the standard method is and what the best way to do it is. And if I could have one ask in that process, if you have any influence, Iain, is that there's also a standardized way of presenting that data. Because if we've learned anything from trying to interpret things like fan curves, if you leave it up to marketing departments, it's a flipping minefield trying to determine performance of this product versus that product, because you can't compare apples with apples. So it'd be great to have some kind of standardized displaying of technical specifications and information, because that means then people can make informed choices based on the information. If it, but the level below the label, the A rating or whatever it ends up being, that there's some standardized tables or something that means people can see how it performs at X and how it performs at Y. Be very good.
Yeah. So that's a good idea. Classically, that has happened by getting rating agencies to agree on labeling. Test methods generally don't do it. But one of the things that I'm working on and it's not just me, there's a bunch of people involved in this, again, from manufacturers, rating agencies, other researchers. What we're working on is exactly that sort of coordination, where we have the rating agencies involved from the very start in developing the test method. So this is something that we should go to the rating agencies and say, please use the same symbols and layout and text and font. So when I'm at the shop and I'm looking at a stack of boxes, the things that I'm looking at are all the same. So
that'd be really cool.
I did want to touch on one more thing that you mentioned, which is all of this is moot if none of these devices get turned on. And we know that they're not always turned on when they should be.
Chicken and egg, though, isn't it? Because they're not turned on because they're horrendous. So if we can make them less horrendous, there's more likelihood that they'll be on, or that they're automated. When we look at the hierarchies of control, when we get down to engineering controls, the preference is always automation. So if you take some of that choice away from people, that at least stuff is coming on when a ring goes on or a hob goes on.
Sure. But I would argue that we'll talk a little bit about automation in a moment, but you should only automate if the thing that happens automatically is acceptable to people. So if the thing that happens automatically is an incredibly noisy fan is turned on in your kitchen that drives you crazy, that's not good automation, right? So we we kind of have like we need to coordinate this, right? We can move to automation once we have quiet, efficient operation, right? And so we're sort of doing these things in parallel right now. So the automation part of it, there's been sort of semi-automation for very, very high-end, expensive devices for quite some time. They were mostly, I would say, a safety measure rather than a ventilation measure. And they were based on things that are very simple, like measuring the temperature in the hood. And if it got very high, it would automatically turn on in high fan speed, because the concern there is something really bad has happened, like there's something on fire on the cooktop. And you want to vent away that fire and not overheat your cooker hood. So that's why it's temperature based, right? So that was sort of a safety measure rather than a indoor air quality measure. But that idea has been around for a while in high-end devices, and the next generation, if you will, are sort of under development. There's a few hoods for sale. Again, they tend to be the very expensive high-end ones that are doing more sophisticated sensing. So it's not just temperature, they're sensing other things as well, so that they will automatically come on when you're cooking. And also change the airflow and the fan speed depending on things like what are they sensing, right? And they can sense, there's a range of stuff, and each manufacturer has their own way of doing it that's kind of proprietary, to be honest. But we know enough to there's almost certainly some sort of temperature sensor, potentially an infrared sensor for sensing heat, possibly a particle sensor, and possibly a humidity sensor. Those are the sort of things you would
I think I saw one.
put in
I saw
hood.
one with what looked like, or like you say, it's pretty proprietary, so they're not giving much away. But it looked like some form of VOC sensor, possibly.
That's
Yeah,
possible.
no, I'm not quite
Yeah.
sure what the performance of those are going to be in such extreme environments. Particulate sensors and metal oxide sensors and things are going to come under a lot of pressure.
Indeed.
But then, it's got to be better than nothing.
But I think the point is that those things are coming.
Yeah.
Automation is coming, but the automation has to be acceptable to the people in the space, right? So you should only do this with hoods that are going to be quiet when they operate automatically. Now we've tested some of these devices in our test labs at LBNL, and in our test they work just fine. Honestly, they seem to do what you would expect them to do. And of course, it gives you the opportunity to do some extra programming. I'll give you an example, which is that we found that if you leave the fan running just on low speed for a few minutes after you've stopped cooking, so you've stopped emitting, you've stopped cooking, you can turn it down to low speed so it's quiet, and keep venting the kitchen for 3 more minutes after you finish cooking. That can have quite for relatively little sort of energy expenditure of running the fan sort of thing, that can really help to reduce the remaining contaminants in the space, because you just keep venting the kitchen with a little bit of, you might call it fan overrun or whatever terminology you want to use. It says, we can have, once you're getting smart, once you're putting something smart in the hood, so it's not just a switch, once you're sensing things and have timers and so on, you can do smart things like that about your ventilation. Say, we know that if we leave the fan running for, say, an extra 10 or 20 minutes, it has this advantage. So we can build that into the programming so that you, the occupant, you have to think about it. The hood was just going to do it for you. You have these opportunities to be smarter about ventilating your kitchen. Yeah, once you've got some smarts in the hood.
There was a question I wanted to ask you, actually, because it's something that's come up in a couple of conversations I've had recently. Actually, one of them with somebody you know well, Marie Coggins. She's also on the AIVC with us, and she's been looking at research on retrofitting at homes, and she's been seeing a lot of kitchen pollution egress out of kitchens into the rest of the house, and it's raising the question, do we have the background ventilation rates high enough in kitchen zones? traditionally we've
Mhm.
tended to have more in the bathroom zones because they've presented a moisture challenge typically. But she gets the sense, and it seems fairly logical to me, that we're getting maybe quite a bit of escape of pollutants into the rest of the property, and then they're hanging around for a longer time because we're not ventilating well enough those kitchen spaces, because residential ventilation's much lower than non-residential
Mhm.
spaces typically. So maybe there's an argument to improve that. But maybe it goes to your point that maybe we can be a bit more intelligent, that there are overruns, a bit like we had with intermittent fans in bathrooms in the past, is that you have, when they're
Yeah.
on, when you finish using that space, there's a period of time where, let's face it, even at half the flow rate, at 25, 30 litres a second for another 15, 20 minutes, that's going to make a big difference to the amount of pollutants that are going to be available to escape.
Yeah, I think the world of ventilation um, is sort of just taking its first steps into being smarter about how we ventilate. We've got smart in a lot of other devices. I mean, I think we're familiar with things like computers and televisions and all the devices you connect to a television and game consoles, all those things. They know when you haven't done something for 10 or 15 minutes, right? And they turn themselves off or whatever, they go into low power mode. We've seen that in every household appliance, but not in your ventilation system, right? And I think we're just starting down this step of being smarter about ventilation, as you say, and including things like, well, let's ventilate at a slightly higher rate because we detected these contaminants, or keep the fans running in bathrooms. I mean, the bathrooms is just a simple timer, right? And sometimes they have a humidistat in there that's ventilating based on humidity. But just sort of basic stuff like that. We're just starting in the world of ventilation air quality to try and be smarter about what we do. So there's a lot of potential there, right? There's a lot of potential to do things in a better way. I think relatively reliably and inexpensively.
And I want to come back to that with you, Iain, because I know it's something that you've spent. In fact, it's what I've known you for nearly a decade now. Is that looking at where the state of the art of sensors and our ability
Mhm.
to measure this? So
Yeah.
I definitely want to come back to that. But before
Okay.
we finish off the cooking conversation, because um, we've kind of jumped onto it, but we've really gone down that rabbit hole, and I think it's great. The Knowing what you know, having probably researched this as much as anybody, what are the basics people should be looking for with cooker hoods? What makes
Mhm.
good cooking exhausting versus bad? And
Yeah.
I'm assuming there are outliers, like those fancy ones that pop up from the back of a cooker and magically pull the air downwards. Must be fantastic
Yeah,
in there.
magic is the right
Yeah,
word.
right. So I'm sure you've measured those. But like, so if I'm out looking for
Yeah.
a cooker hood tomorrow, what are the kind of things that you've seen work, and where do you see a
Mhm.
fall off in performance then after that? If you were going out
Right,
looking tomorrow, what are the kind of cooker hoods that you'd be looking for?
right. So you've already raised the classic problem of where should you be sucking the air from, right? The answer is from the top of the cooking, because if you look at the plume of contaminants, they go up, right? So if you have the terminology we use is a downdraft system, and sometimes it's just a vent. Sometimes there's a little thing that pops up with vents in. They have a very hard time because what they've got to do is they've got to take that plume of contaminants, turn it around, and suck it back down again. And all the tests we do show that's not particularly effective. I mean, you're still ventilating the kitchen, right? You're still exhausting, 100 liters per second or whatever the airflow is from the kitchen. So it's not they have zero effect. It's just their efficiency is poor, right? If you had that same fan and just had it mounted in a wall or window exhausted, again, you'd ventilate the kitchen and it would have some effect. It's just not an efficient way to do it. You have to move a lot more air to get to the same contaminant concentration. Right? So it's much better to have something over the top of the cooking. I mentioned earlier this issue of often you want to cook at the front of your device, whatever it is, whether it's cooktop or a range in the US, whatever it is. To effectively capture that, you do need something that comes out far enough from the wall, or if it's in an island, is physically large enough that it covers that area. The better you cover the area, the better. And absolutely, there are trade-offs there. I mentioned the one earlier about then you might be bumping your head in all the time, so you have to mount it a little higher. But okay, so there's some compromises, but that's figure outable. So physically large is sort of one idea. Another one has to do with there's the potential for other what I would call geometry related things to make a difference. And here it gets a little more complicated and harder for sort of an individual person who's shopping to make these decisions, because you have to know a little bit more about the product. Look up from where would if your head was on the cooktop, if you look straight up, what do you see? Right. And if you see like a little metal grill that's only a few centimeters by a few centimeters square with some metal mesh in it, and it's stuck right in the middle, or sometimes they're off center, those are not going to be great at capturing the contaminants from all 4 hot plates or 6 hot plates, whatever it is you've got. They're just not going to be very effective. But if you have a big open area and it's over the whole area, they're going to work a lot better. Right. So there's some like critical geometry things. After that, there's some oddities that I think are less prevalent in Europe, but we see a lot in the US, which is we put our microwaves above our
Sartorius was talking about this on the podcast the other day, and I had no idea. But now I think of American television, and yes, you see it all the time. And that's this thing about microwaves above a cooker. Yeah, that's a thing.
Yeah. So that happens all the time. And the question is that an effective hood? And the answer is sometimes yes and sometimes no. We've tested ones which were just terrible and others which worked out okay. But unfortunately, we don't have a rating system in place yet for you to know that. This idea, you said, if there was a good label, you could pick the microwave that was better than the other one, right? Once we've got a good label. You can't do that right now, but I think you will be able to in a year or so. So, and microwaves add this complication of they not only have vents in the bottom, but they also will have vents in the top, like along the top of the door and other interesting things. And they have a very different airflow pattern that they set up. And so it gets a little trickier to measure them, right? Because they're not like the other things. But we've had very mixed results for microwave hoods. Like I said, some really didn't work well, and some did. And it really depended on things, I think, like where are the holes in this box, right? Where's the air getting sucked in? And how effective is the fan?
Yeah.
Right. And a whole bunch of other things. And I think one of the critical things for the range hood models we see in the US is they struggle with the noise issue, because you can imagine the passages that the air has to go through, they're pretty small because they've got to wrap around there's still the microwave oven is still in there, right? They've got to wrap around it. They're small, they get noisy. So they have noise challenges as much as anything else, right?
Yeah, interesting.
So, but
do these things fundamentally affect how effective the flow rate ultimately is? The flow rate pretty arbitrary because the other confounding factors make such a big difference? Or have you seen kind of volumes of airflow that just make a fundamental difference? So that you were kind of mentioning 50 litres a second or 100 cubic feet a minute or whatever. I can't remember what you said, but is there some kind of volume thresholds that you see? Yes, you start to see a reasonable difference here.
Absolutely. So at the minimum airflows we use in the US, which is 100 cubic feet per minute or 50 litres a second, there can be a really big variation in efficiency. Could be as low as like 20% or less, but maybe it's over 70%, depending on the device that you're looking at. So a huge range to low airflows. But once you're above once you get to higher airflows, by higher airflows, I mean greater than 300 cubic feet per minute, or about 150 liters a second. Above that, the differences get much, much smaller, mostly because at very high airflow rates, just about anything is going to be good at capturing that plume and throwing it outside. Because what you're changing effectively with the volumetric airflow rate is you're changing the mean air velocity in the air entering underneath the hood. And this is an air velocity / momentum thing. We're not going to get deep into the physics or the science of it here, I promise. But there's a momentum in the plume, right? It's hot air. And we know roughly what velocity it moves on its momentum. If that momentum is bigger than the velocities and momentum associated with the air entering from the kitchen, then the plume can escape. If it's lower, it's less likely to escape. Right? And what happens is a high airflow.
I think people can imagine you take a lid off a big boiling pot, you see that plume of steam coming up.
We've all seen these plumes.
Big curtains of it plume outside of the cooker hood if it's not exhausting fast enough. But if it is, it will suck it up. You get a totally different shape of plume. If it's working effectively.
If you're boiling a pot of water, you can do your own fluid mechanics experiments in your kitchen any old time by stand to one side and see how well it's captured and turn up to high speed and see a change. You can all do it. It's relatively easy. But the point being that at the high airflows, you've induced such high velocities in the kitchen towards the cooktop that you can basically overcome the plume and you'll have very high capture efficiency, and it won't matter so much the specific geometry of the hood anymore. When you're at very high airflows, you get over something like 85 or 90% capture efficiency, no matter what. But the reason we don't see that done very often is that's when it's super noisy, right? That's moving a lot of air. But the point, to answer your question, the variability is in the airflow range, which is below that for quiet operation, which is what people want to use, and rightly so. And we're trying to set minimum standards for that, for those airflows that are generally lower, particularly down at mandated minimums, right? That's where we want to set.
Yeah.
We want to say a minimum of 100 CFM, but you must also have, let's say, 75% capture efficiency at that lower airflow. So, because we could set like we could do something that wouldn't really change anything. We could say, well, you've got to be above 80% capture efficiencies at the highest airflow possible. Well, almost all the hoods will do that, right? There is an exception to that, and again, Simon, you're already telling everybody everything I know, which is that there are different grades of hoods. There are high-end, expensive hoods, and then there's, in the US we call them builder grade. This is the least cost product, right? That is built down to a price. It has the cheapest switches in it. It has the poorest. The blower motor is the cheapest. The fan blades are the cheapest. Everything is the cheapest. We call it builder grade because that's what everybody wants to put in new builds. And when you buy them in bulk, they are very inexpensive when you're buying thousands of them. And they're built down to a price point. Those tend to not be able to reach high airflows, frankly. They have to
quite frankly, they don't even hit your minimums.
Right.
Yeah.
They don't have a good blower in them. And the other thing that challenges them is that they are often rated basically with no ducts attached. But in any real kitchen, I guess the exception would be if you can go straight out through the wall. So the length of duct is a few centimeters. Okay. But we often find in kitchens that is not the case. Often kitchen vents go, say, vertically up from the kitchen and up to a roof vent. Or they go up for a bit and then they go out to an eave vent, and they can have several meters of ducts with elbows attached to them. And there's definitely going to be a rain hood on the outside. All that stuff is airflow resistance. And if you've got a good blower, it's like, I can still move the airflow required. But if you have an inexpensive blower, it will not do that. And you alluded to this, which is that we've certainly done plenty of measurements in people's homes where the actual measured flow is nowhere near the rated flow. And it's because you have to account for all this airflow resistance. And,
Yeah.
there are some other things like over time, you get grease buildup and things like that, and dust inside the hood mechanicals, right? On the blower wheel, in the motor. And those all conspire to reduce airflows as well. But that tends to be a gradual thing over many, many years, right? You will definitely see a degrade in performance. But I'm talking here about when the device is brand new, it just got installed into the house, it got connected to 5 meters of duct and 4 elbows, and you turn it on, and you don't get the airflow it says on the box. It's
Not
much
even
reduced,
close. Yeah.
right?
Because the pressure drop on crappy flexible ducting or cheap ass plastic ducting with crappy outlets, even at 30 litres a second, the pressure drops down that stuff are so horrendous that the fans that are trying to overcome that just don't stand a chance. And the bad news for my UK listeners is the average airflow that I've measured on kitchen hoods in the time that I've been doing it over the last few decades is well below 15 litres a second.
Yeah. That's not
which
effective
is
kitchen ventilation.
No, not even close. Yeah. And that's what we're facing is that builder grade. What's the cheapest possible solution I can? Because what goes with that then is a cheap installation and lack of thought and design and so on, and you get a very, very poor outcome. So, for context for everybody, the vast majority of you, unless you happen to have built your own home or put a decent range hood in or something like that, for the vast majority of people, their cooker hoods are not going to be doing what we want cooker hoods to be doing. And that's a challenge. But I think labels and some kind of standardization of that will have a very big impact, because at least that's a starting point. And it frames a value that we've not had before, because genuinely, if consumers aren't asking, oh, what's the performance of that cooker hood when they're going around and visiting homes they're going to buy, nothing is ever going to change. And that's the challenge. Or when they're going in to buy a new cooker or replace a cooker and a cooker hood, that there's some minimum standards that these things will have to achieve. And with that will come guidance of installations and so on.
Yeah, in the US, we're working on the minimum standards part of it. And partly to recognize the issue you and I have just talked about, which is we have to understand how these things are installed. Right. And so, again, we're working with manufacturers and rating agencies to actually rate at a different rating point. So instead of it rating effectively at no airflow resistance, which has kind of been the industry standard, that's not going to happen in the future. We're going to rate it's effectively a fixed airflow resistance. It's supposed to represent, several meters of ducting, and I think it's 2 elbows and an outlet vent. Anyway, it's a standardized thing that we've basically all agreed. This is how we want to rate things. Again, your mileage may vary in your kitchen, right? If you have longer or shorter ducts, obviously that's still true. But we want to take that first step from what is frankly a very unrealistic rating point, which is effectively no airflow resistance, to something which is like, oh, okay, you might see this in a lot of kitchens. It's much, much more representative of the real world performance. What it's going to do is, it's a minimum standard thing. It sort of puts a performance floor. So the very worst devices, they will not be able to get rated, or rather, they won't move in a flow that they will be able to say we meet the minimum airflow requirements at this new testing point.
Yeah.
And the terminology that we're going to use is in the US is something called nominally installed airflow, NIA. So that, in other words, we're changing the rating procedure to try and better match what we think happens in actual kitchens.
Yeah.
It's going to take a while, but we are definitely trying to change that. And if only this was international, it's going to happen all over the world, and but it's not, right? This is a regulatory change and a ratings change, and it's going to go country by country, is my guess. But I think somebody has to do it first with a lot of these things. If one country decides to do it, manufacturers selling that country now have to rate under that method. And it becomes much easier for the next country or the next rating organization to say, oh, we want to account for that as well in our ratings. And so now we're going to do it. So hopefully, to help your UK listeners, Simon, once you've done it in the US, the UK can then go, oh, we think we should rate this way too. Yeah. And particularly as if key manufacturers have already changed how they rate, then you need the manufacturers on board with these rating changes. Otherwise, it just decays into years of back and forth over how you're going to have regulation changes. And the way to do regulation changes in an expeditious manner is to get everyone on board first, right? And I think we're kind of doing that already. Yeah. But pretty soon in the US, that's going to be the standard. Is you'll have to have a pretty good blower in your kitchen ventilation system for it to actually perform at the minimum level that we're going to require.
And I know it's quite state by state in North America, particularly when it comes down to the regulation or the control, the standards on the ground. Where are things generally with that kind of independent inspection of standalone ventilation systems? Because that's the other bookend of this process, is the standards of defining how a product performs, but also then standards around checking the installed performance of ventilation, kitchen cook hoods being one part of it. But that for me is the other area, I think, where we can start to capture this a little bit better, is actually measuring the performance. And I know cook hoods can be much more challenging to measure, especially if you don't have access to the terminal on the outside. Measuring the actual cook hood can be near on impossible. But that's enough, because like I said, I can count on one hand the amount of time in 20 years I've seen a cook hood actually do what it's supposed to. And that's the other way of correcting this situation, is that if people start seeing poor performance, measured performance, you can start holding people to account and say, hang on a minute, that's supposed to be doing 50 litres a second. It's only doing 20. Fix it.
Indeed, as you say, the challenge for kitchen ventilation equipment is actually doing the measurement. It can be easy, but often it isn't. Yeah. Right. As you say, if you don't have access to the exhaust terminal on the outside of the building, it's hard, right? Which is why we're going down this changing the ratings route. Yeah. To sort of bypass that. The idea is, if you change the rating so that it's challenging enough that you can reasonably believe you'll get the right airflow when it's installed, we believe that's probably the easier way to go, because it is just so hard to measure exhaust airflows from cooker hoods. It's easier in bathrooms, for example. Bathroom fans are quite easy to measure. There, you can go and get very relatively simple airflow measurement devices and do that. But it's just all the range of geometries and actually getting something between the bottom of the cooker hood and the cooktop. And I mean, frankly, the high-end research we do at Lawrence Berkeley National Laboratory is we take lots of cardboard boxes with us. We go to people's homes and we literally custom fabricate out of cardboard and tape capture boxes that we then attach pressure equalized fan to. But you can't do that on a production basis. No. Right? I mean, you can, quote unquote, get the right number that way. But no, that's not something you can do on a production basis. Only researchers will ever do it and should ever do it, frankly. Yeah. I mean, you could make the argument, though, that there should be some sort of built-in airflow device. I'm sort of going back to, can we be smarter about indoor air quality and ventilation?
Well, so much of the ventilation.
Why should it be an airflow sensor?
Yeah, well, so much of the
Sorry, I talked.
Yeah, no worries. So much of our of the ventilation technology we're seeing in homes now are constant volume fans. They have their own calculation methodology in there. They know how fast they have to go at certain pressures to deliver certain volumes. So you set the fan to do 15, 20, 30, 60 litres a second, and it will spin as fast as it has to achieve that, knowing the pressure drops and things that it's facing. Either that, or you provide ports in the ducting or in parts of the machine to be able to take a reading, at a known diameter of ducting or something. There's a million ways this could be done practically if it was important enough to do. If you made it a requirement.
It has to be a priority, right? And at least in the US, I'm talking here not just new construction, but if you're doing a major remodel or of a kitchen or a home, the priority for most building code inspectors are life safety things, like have you used the right wires when you wired up the home? If you've installed a gas line, is it the right diameter? And structural things like have you used the right either dimensional lumber, or if you're doing masonry construction, have you used the right metal reinforcement rods the roof won't fall? Those are sort of like construction safety things. So things we're talking about are kind of new and frankly still low priority, even after all these years of working on having air quality and ventilation standards in buildings. They're still kind of new. So we have to make it easy, is my view. And I think some of the ideas you've talked about, there should be a push to test button for any building inspector or installers, even like the electricians or whoever's installing. It should be a push to test, green light, red light, tells you if it's working or not. We need to make it easy to determine this and not require you to like fabricate your own flow capture out of cardboard, because that's nonsense, right? It needs to be easy, because if it's not easy, it won't get inspected and no one will ever care, right? The only time people will care is if it becomes a significant thing. And I mentioned this earlier in the podcast, Simon, is that when we have surveyed people to ask them how often do you use a kitchen ventilation or a cooker hood, and if you don't use it, why not? The common answer is it's not needed. Now, so when people say that, if they're frying something and there's lots of smoke or something, they will definitely turn the hood on. Those are our observations. Is when there's obviously something where you're like, oh, we better vent this right now because the house is filling with smoke and the smoke alarms have just gone off. Then the cooker hood gets turned on, right? When it's seen as when there's something obvious saying we'd better vent this. But most of the time, no, because we're like, what is the problem here? There's no, people have been cooking for centuries and people didn't drop down dead or whatever, whatever story people tell themselves, because that's how people make decisions, is the stories they tell themselves.
Full circle back to risk communication, isn't it? Really, it's that I don't perceive a problem, therefore why would I turn it on?
Exactly. Yes.
Before I forget, it was one of the things I said I'd definitely come to you on, was we can see the air better than we ever have been able to, more affordably than we ever have been able to. And that's changing the narrative ever so slightly and potentially quite fundamentally, in that it becomes much less about whether your product was compliant during manufacturing or your home was up to code. Objectively, you're going to be measuring the performance of your building on an ongoing basis. And one of the things you might be measuring as we go forward is air quality. So does it matter how good your cooker hood is if you don't produce the pollutants that are of concern? Then do you care? Or if you've got a decent cooker hood, but you do so much cooking that you're just exposed chronically to higher levels of pollutants from cooking, then that might be more of a problem to you than for somebody that doesn't. When you start measuring outcomes, air quality outcomes, it changes the narrative. We're struggling here to get people to deliver aerolic performance, air movement performance, which is like the fundamentals. And I have this argument the whole time that how do we think we're going to cope with trying to adjust for air quality outcomes when we haven't been able to deliver air movement performance outcomes to date.
Mm-hmm.
Objectively, we've failed to do that pretty much in the built environment. But we are starting genuinely to move into this era now where somebody's going to see that they're getting a lot of particulate matter spikes in the living room every time that they cook. That's a different narrative, isn't it? When you start looking at air quality outcomes as opposed to air movement outcomes.
Yeah, I think so. I mean, there's a lot to unravel here, but the advent of relatively low cost, what I would call consumer grade air monitors, that are, you can just go buy one, right? It's relatively trivial. They're not free, but they're not super expensive. The laboratory grade particle sensors we use are like 70,000 euros, and no one's going to have that in the house. But what if you can get something for a couple of €100, right, with a nice little display on it, which is what you're talking about, I think. And actually, the advent of the particle sensors, I think, were the thing that really pushed this. And here's why. These optical particle sensors got produced in a way that they became much more reliable and lower cost. And now you could conceivably put one in a little box in the house. Before that, we did temperature and humidity, right? Was sort of what we classically measured in homes. Temperature, we've used temperature to control things in a house forever. People have had thermostats in homes for more than 100 years, right? Humidity, we talked about ventilating bathrooms, for example. Ventilating your bathroom on a humidity control has been around for decades, right? But once we could measure particles, we could say something much more definitive about the health aspect of air quality. I think that's the important thing. It brought in this health idea. Because particles are the number one thing in terms of health impacts. And now we could measure it relatively inexpensively. You could put one of these in a box and sell it. And people, as you said, can watch what happens in real time in their homes to particle counts. Often these devices sense other things. Your listeners are probably familiar with TVOC, volatile organic compounds, right? I'm not convinced that's a great measurement for a host of reasons. We can talk about that later.
That's a whole podcast in of itself, Ian. I think the value or not of TVOC monitoring.
But being able to do particles and sometimes CO2. Yeah. Again, we have to be careful with CO2 because not all of those consumer-grade devices are actually measuring CO2. Sometimes it's inferred, and the ones that infer it are worse than useless. Yeah. They're usually, they don't even get the direction right. It's not even worth doing. But some, if you read the fine print, you have to read the fine print, that has a real CO2 sensor in it. It tells you something about the general ventilation rate that's good for perceived air quality sort of thing, right, for general ventilation. But I think it was the measurement of particles really was a game changer there, right? Because particles are used in ambient air quality indices that, at least in the US, have been around for quite a long time. Your daily weather report on the television, for example, would have a little box in one corner that had something called the AQI, the Air Quality Index, telling you it's mostly particles, but some other things in there too. And there's a network of sensors all over the US. And I'm pretty sure you have these in Europe and probably other parts of the world too, for outdoor air quality. So this concept has been around for a while. People have seen it on newscasts. And sensitive populations have been tracking this for a long time. At least from the outdoor air quality point of view. What these devices have allowed people to do is to now do it indoors. And I think that the early adopters were mostly from what I would call sensitive populations. So not average people, but people whose health really does depend on air quality. Asthmatics are the classic subset of people who are sensitive to air quality, but there are also the elderly and young children are certainly have increased sensitivity to contaminants and pollutants in the air. And I think that there's been some pretty widespread adoption by that sort of subset of people. Then there are people who are just generally more concerned about their health. like out of the population, there's a fraction of people who were very concerned. Like they saw this device, let's get one and see what's happening in our home, right? But I would call those people the early adopters. The question is it ever going to be that every home has this? And this is just my opinion now, based on nothing but my opinion and experience of this, and trying to do things in people's homes and meeting a lot of people and talking about air quality, is that I think that for most people, they just want healthy air and they don't care how they get it. It goes back to our conversation earlier about people want a warm, comfortable home. They don't care how they get it, right? They just want it to work and have it automated so they don't have to be air quality experts and do it themselves. I think at the mass market scale that we have to automate it. But what helps you get there is you have to have early adopters do early adoption. What the early adopters are doing in this case, I mean, people are early adopters about being concerned about indoor air quality. They're using these monitoring devices, and it's a game changer in that sense. It's really raising awareness. And I think two other things have really changed in recent years. One thing in North America and some other parts of the world too has been much, much worse wildfires than we've known historically for quite some time, which would result in very, very bad outdoor air quality and also poor indoor air quality, lots and lots of health impacts, hundreds of millions of people affected, so wide scale disruption. Just easy, our air quality challenges, generally you can't see it, but with wildfires you can. And that was a huge trigger for people to think, oh, should I be breathing that air? And what's in that air that's dangerous? Why would I not want to breathe it? Should I be monitoring this in my home? This certainly in the bits of the US that got wildfires, which is now most of the US and Canada and Mexico also, huge awareness raising. Then something else came along, which was COVID-19. And that was another sort of escalation of people thinking about air quality. In this case, it wasn't particles per se or some of the other volatiles that are in smoke. It was this idea that you could be infected with an airborne virus, right? And people started thinking about, should I be wearing a mask? Should I be filtering the air? Should I be ventilating? All these questions that are all air quality questions effectively. And those two things have again, really, I think, changed people's thoughts about this. But I think in general, people didn't think about air quality very much, but now they do. And when I say people, I'm talking about, generally overpopulation, who would care, right? I think the awareness has gone up a lot. And what I think we need, we being sort of the indoor air quality industry, to respond to that, we need good answers to people's questions. We need to be able to say, oh, well, we've got these automated sensor-based devices that will control your ventilation systems and maybe shut it off automatically if there's a wildfire, or maybe increase it more if there's a button you can push, which is the I want more airflow button, or I want to turn on some filter button. Maybe that could be automated, but you should give people these options because now they want to use them. People have awareness. They're like, well, maybe I should be cleaning my air or ventilating more or ventilating less during a wildfire event, in fact, right? But from a residential perspective, it's less so for commercial and large buildings. For residential perspective, the industry is not there. The buildings industry has not really responded to that I see in any significant way, and maybe they should. But as you say, unless people demand it, builders and contractors, it's a hard sell for them. They're going to sell to the early adopters and have done, right? That's happening. But for it to be every home, I think it's going to be this balance of increased sort of general public awareness and the availability of things that make it simple, easy, and automatic. Yeah. I think those two things need to happen in concert. I'm not so sure the second of those things is happening, but it's possible, right? I think we have enough confidence in our sensors to automate some of this anyway.
Yeah, we're getting close. So and it's been interesting to see your research over the years, how the view of these low cost sensors has changed, and where we seem to hit thresholds where all of a sudden there's a an underlying confidence in a way of measuring a certain parameter. We saw it with NDIR sensors. We saw it with optical particle counters for PM.
Right.
And what's interesting, and to add to your point about, PM is a specific pollutant of interest, whereas CO2 has always been a bit of a proxy. TVOCs are a proxy,
Mhm.
temperature and humidity are a thermal comfort proxy. They will have an impact down the road on condensation, damp, and mold, but they've all been kind of proxy based, whereas PM was really the first sensor, I think, that we've got confidence in, broadly confidence in the what we're
Yeah.
seeing, and it actually has a direct health outcome. It'll be interesting to see, and we're starting to see more and more confidence building in some of the electrochemical sensors now that are really zeroing in on some of the pollutants of interest like ozones
Mhm.
and formaldehydes and NOxes, and how they develop over the
Mhm.
next few years. I'm talking to a number of sensor manufacturers who have increasing confidence. They're getting more and more bullish about the confidence they have in their sensors. They're not perfect, but they're getting better. And be interesting to see
Yeah.
as we build up that picture how things change.
Yeah. I think we're going to need some sort of standardized rating way to approach that. So we talked about this for cooker hoods, right? But um, I think we're going to need there needs to be some sort of tests that we run these devices through to see, how good are they really? Because we do see people making a lot of claims, and I can tell you from some careful laboratory studies that those claims are not always true. But how do you communicate that on a consumer level? Right? There aren't necessarily rating agencies for TVOC sensors,
Yeah.
right? That's not a thing, and we might need to have that. I feel, because I think it's relatively easy for people to manufacture a device and claim it does lots and lots of things, but does it really? Right? Is not always obvious, and there have been efforts that to provide sort of public information on this, but they're not organized in any realistic way. I mean, there's just oddities. Like in Southern California, the Air Quality Management District there has tested lots and lots of air quality sensors. Multiple units to look to see if you buy multiple units, are they all the same? And from many, many manufacturers. But that's sort of buried in an obscure part of the internet. No one would ever go looking, right? It's experts only, really. That's not useful from a consumer perspective. Like, so some of this testing has happened, but it hasn't happened in a way that's visible to consumers. It's only for particles, really, to be honest. The other things have been done so well. And until we get out of that, I don't see how we're going to be able to give consumer confidence in these devices. And you mentioned earlier that maybe we need to get away from possibly saying it's an airflow issue and just control for contaminants. That could happen. We'd have more. You could use these to control. I'll call it an air quality system rather than a ventilation system, because I do want to include things like air cleaning devices. The classic air cleaning device is, a standalone air filter that many, many people install in their homes during the wildfires in North America. And you know what? They really do
Do a
work,
job. Yeah.
right? They have a good filter. They really cut out that PM 2.5, which is the critical thing. But that's sort of a consumer. Again, it's a consumer device that works well. It's not automated or integrated into a building in any way, right? You, the consumer, have to go out and purchase it, put it in the room you want to clean, turn it on and off. I mean, they have some automation built in, right? I mean, the one I have at my house and many others do this. They have some sensors in them, and they will do things like they will change the fan speed and increase the fan speed if they think that the contaminant levels have gone up. It isn't clear exactly what they're sensing, right? And again, it's like the cooker hoods earlier. There's a lot of proprietary things going on where you could saw one of these things in half and find out, is it actually a little VOC sensor, or is it a little particle sensor? You could do that, but it's kind of proprietary mostly.
Well, I think once it matters enough, somebody pops up on YouTube that does the cutting them in half YouTube videos and seeing what's in them.
I believe the information is available.
Sure.
Yes.
You know, and I've had interesting conversations with house builders that along the same lines as car manufacturers, that there's different levels of presentation of this information. You know, data's got to be actionable. Otherwise, there's no point having the data. So it's fine to say you've got high particulate levels in your living room, but if you can't do anything about it, it becomes useless after a while, right? So there's got to be that agency and actionability out of data. And we're seeing that very much so with the Internet of Things and data being productized and solutions being provided and sold to people, that the stickiness of those solutions are very much based on, does it actually improve outcomes for me? So I think that's encouraging to see markets developing that. And we see that in social housing a lot, you know, low cost sensors connected to platforms, providing very useful information to drive better outcomes. But below that, and the conversations I've had with house builders have been a bit like with your car. When you take your car in for a service, now the technician plugs it in to see how you've been driving it, what the oil viscosity is, what the level of the brakes are. You know, all of that information is available to him at a service level. To you, that information is presented with a couple of red lights that blink on and off on your dashboard. But below that is a layer of data that's available for the technical people that are involved in that product to deliver a better service. And a layer below that again, that data goes back to the manufacturer to help them improve safety and warranty on products and longevity and robustness of the things that they build. Yet our car isn't even close to the largest purchase we make in our lives. And we don't have any of that data coming out at that level out of the built environment. And the conversation I've been having with house builders is, you're having to make, and it goes back to the beginning of our conversation, increasingly more complex and nuanced discussions on the type of products that you use and the types of services that you put into houses and how people are going to use them. And data has to become part of that picture for you, because you can't manage what you don't measure. You can't improve your product and streamline it if you don't have that feedback loop. And the built environment seems to be one of these industries that just hasn't caught on to that. You know, that we're not making decisions on how we build our buildings based on data. It's almost completely on slow historical progress and anecdotal feedback is the way that buildings get built and improved over time. So we're getting close. I think it won't be long before your service technician plugs his laptop or connects his device to your home to see why the boiler's playing up. And it won't be long before the house builders are slowly improving those products, because the data they're getting back from the heat pumps and the thermostats and all the devices that are collecting this environmental data are providing a picture that enables them to make more nuanced decisions and A and B profile solutions, and how you communicate stuff. Because as one developer told me, if you build 1,000 homes, you can guarantee that at least a dozen people that move into those homes will move in with sensors, and they become very annoying WhatsApp group people quite quickly on your estate saying, you sold me an A-rated home and here's the data to say it isn't. You know, and we're seeing that in the workplace environment as well. You know, you have 1,000 employees, you can guarantee a number of them have got air quality sensors on their desks now at this stage. So it's coming whether you like it or not. The choice is, do you get on the front foot and get ahead of it, or do you have a reactive business the whole time and have to deal increasingly with people ringing you up and going, the air quality in this new home you sold me is rubbish. What are you going to do about it?
Yeah. Indeed. I mean, sadly, I think the picture you paint is correct, and the risk the risk and cost analysis for larger corporations anyway will be, so we get some lawsuits and we get sued, but maybe we'll just pay those lawsuits because it's cheaper
Yeah.
than changing our business practice. I mean, I don't want to be like too cutthroat about it, but that's literally, the history of manufacturing is riddled with these sort of things. People are like, yeah, the product's not 100% safe, but we'll pay off. We think there's going to be 100 lawsuits that each be 10 million euros. We'll pay that off. That's cheaper than us actually fixing the product. I won't mention any names, but Ford Pinto, right? That was the classic thing in the US, right? They knew there was this design flaw, but they figured it was cheaper to pay the lawsuits. Now, that's a very cynical approach, right? And I don't advocate that approach at all. But I'm just thinking to fundamentally change large corporations. That's how they think. But I think that the building industry, it's really kind of quirky, right? I mean, to some extent, it still hasn't had the Industrial Revolution. Particularly in the US, we are cutting bits of wood to length on site and hammering in nails. So nothing has changed, right? There is no industrialization of it whatsoever. Now, you could say to me, oh, yeah, but there are some factories making houses and panels that are assembled on site. And I would say, yeah, but that's such a tiny, tiny fraction of construction. And for building renovation, almost none of that. Although, again, there are some like little baby steps being made. That's tiny. So that industrialization never happened in the buildings industry, which means that they're way behind when it comes to adopting these ideas you're talking about that are commonplace in automobiles of there's one port, everyone agreed what the port looked like, you plug it in, tells you everything. That implies some sort of standardization and industrialization, which does not exist in the buildings industry, pretty much. And again, and buildings are a weird thing. With an automobile, yeah, parts are pulled in from all over the world, maybe, but it's assembled in a factory under very controlled conditions somewhere. And the manufacturer of the car is in one way or another responsible for every single part of it. Whether it's, cars have air conditioning and heating. They don't make hot water. I mean, maybe they should if you want tea, but that everything built into the car is the responsibility of the manufacturer. In housing, we just don't have that. It's highly fragmented, right? The devices that heat the home or make the hot water or whatever, they're not, it's not all brought under one roof. There isn't one person responsible for it. You call the individual companies that manufacture those things if there's a warranty claim and all this sort of stuff. It's really, really hard to pull it all together because the industry is not structured that way. So this is less of a technology problem than maybe how an industry is structured issue in terms of how do we get everything to pull together. So the manufacturers of heating and cooling systems are not the same as the manufacturers of ventilating systems, who are not the people who did the air sealing. They're all very separate, all different companies doing it, right? And so there's nothing pulling everyone together so that the manufacturer of the heating cooling system knows that there's an actual heat recovery ventilator and so they can reduce the loads. And neither of those companies manufacturing those know anything about how well air sealed the structure was that it's all getting installed in. This is all done in a very ad hoc, unplanned way, to be frank. And this is why the things you're talking about, we just don't observe in the building industry because the building industry is not there.
But interestingly, I think where we are now with technology, particularly with connected devices, environmental sensors, Internet of Things, we're able to pull together strands of data from different sources relatively easily through APIs and connectivity of different systems online and build a picture of performance of spaces without needing that coordination. We can take weather data from a local weather station. We can take sophisticated temperature and humidity data from a smart thermostat. We can take electrical meter data from a smart meter connected to someone's home. And we can calculate heat loss transfer coefficients in that space because we understand time to heat and time to cool normalized with outside temperatures, and we can see the energy input into the house. And all of a sudden, we've got a live co-heating test going on in that home 24 hours a day, 7 days a week, 365 days a year, with 3 bits of data that are online anyway. And that's the power. I think that's the era that we're moving into, is that all of a sudden you suddenly create a performance KPI for a building, and it's not your KPI. Some other flipping company does it and causes you trouble. That all of a sudden you can map and look across an entire district and see which homes, which brands are performing worse than others. And that has an impact on the industry when all of a sudden you go, well, you don't buy a Bellway home because their extra urban miles per gallon figure is lower than the wimpy home, and all of us, it doesn't take long for some clever, annoying wallop is putting up a league table on the internet of how energy performance those homes are, and causing unknown trouble.
Right. That all sounds very interesting, but I wonder if that's going to happen. So, an issue we have, at least in the US, is this: that you're right that if you have a smart thermostat broadcasting to the internet, you can log temperatures, not a problem. Heck, if you've got 3 or 4 thermostats in your home, you could do zonal temperature. You could have all that information. You could do the same with metered fuel use, right? Whether it's electricity, gas, whatever, you could certainly do that. The challenge is there's all this other sort of what I would call metadata that someone has to have recorded and make readily available. Like, okay, so I know the temperature in the house, I know it's fuel use, but how big, how many square meters is that home? You better know that, right? And if you're going to rate these things, you have to know things like, is it sheltered from wind and sun at all, this home? So I can do an oranges to oranges comparison, because an isolated home on a hilltop isn't the same as a home in a street, right? And particularly if you're going to put solar PV on the roof, you've got to think about, what if this house just has big trees next to it? That what I call the metadata, so the stuff that isn't recorded automatically, is the challenge if you want to do those sort of league table things, because otherwise you don't end up with an apple to apples comparison. And I'm not saying anything new here, right? This is something we've known for a long time about energy efficiency rating of buildings. There's a lot of other things, and things like, what if one person lives in the house or 6 people live in the house? It's the same house. If you want to compare, how much energy they're using for hot water, it's very different. Right? Or the energy that they're using plug and lighting loads. Right? So these are some of the challenges, and we'll end on a positive note. I'm just throwing all the negative stuff out there because this is what I have to deal with on a daily basis. And the challenge, I want to outline the challenges we would face to get to your idealized world. So in the US anyway, there are also quite complex legal barriers about sharing the sort of data you're describing, like the temperatures inside someone's home. That's not shareable data. Billing data from your utilities, your power company, that's not easily shareable, because we protect people's personal information. The number of people living in a home, that's not shareable information. And so there are challenges there that I think they are real, right? We shouldn't automatically assume that all that information about people's lives will be freely available. Obviously, you can set up a system where people would opt in, right? There could be, every time they get an email with their new electric bill, there's a little link that says, if you want to opt into our system of whatever it is, click here. So you could allow people to opt in, right? You get their permission to share their billing data. In the US, we actually have a system called the green button. It's not literally a green button. It's a virtual green button, but you can opt in to sharing your personal data about what is your electric bill, for example. So I think, oddly, the legal challenges about what we do with personal data are very important. when we talk about these systems. And I know that particularly in Europe, in some ways, Europe is more sensitive, I feel, than we are in North America to these things. Every website you visit that's European-based asks you a lot of questions about sharing your personal data and what cookies are being exchanged and things like that. And I think that is a significant challenge when we talk about all this technological integration, is about the legal aspects in terms of what is personal data and what isn't personal data, and should people have to opt in, or are they automatically in and have to opt out? And the lawyers for this podcast will be able to tell you the answer to that better than I can. But it's not an insignificant issue. And
well, I mean, if you look at a sector that's probably the most advanced in this at the moment, which would be the UK social housing sector, I would say. So the proposition is this, that a landlord is going to be putting a device in your home that is measuring things like humidity and temperature and the kind of behavior that might be causing problems with damp and mold. The refusal rate for environmental sensors going into social housing is less than 1%.
There we go. So that might work out.
So my point here is that, like a lot of personal data, I don't think people give a monkeys about personal data if it has a value to them, giving that data away. The amount of information we all both give away on our mobile phones is horrendous, obviously. But we make a decision that the value we get from that data is worth those sacrifices if we're making a conscious decision about it. A lot of people aren't making that decision.
Sure. Yeah, that's fine.
Same with the home. I think if you think that these devices are going to enable you, empower you to make better decisions about your home, then it's the kind of data that people seem to be, on the surface of it, quite willing to give up, I think. The proposition for tenants is that it enables their landlords to provide a better service, that enables them to say, look, I've been telling you I've got condensation, damp and mold for 2 years. Look, the data tells you so.
Well, yes, people might not the answer.
Amazing.
Sorry, people might not like the answers to those questions, right? Is the thing. And to be clear, I think you're right that many individual people, if you ask them, do you want to opt in, they will. The issues are ones raised by lawyers who say to people like me as a researcher, they're like, you simply can't include those things in your R&D because legally we think we might get sued, and we're worried about getting sued, so we don't want you to do it. So the feedback I'm getting is not that individuals might not want to be involved. There may be some that won't, but the lawyers won't allow me or major corporations to do it because they're worried.
Yeah.
It's a risk for them. They're worried about getting sued. That's the roadblock, if you will, to enabling that sort of thing. It's a legal profession, not an individual's choice.
Well, look, it's going to be fascinating to see how that develops over time. As I suspected, Iain, I only got about a quarter of the way down the questions I'd planned to ask, as is all of our conversations.
We can meet again, obviously, in the future. There's still lots to talk about. There's so many things about air quality we didn't get to, and we'll talk next time about this sort of strong link that we think there is between changing the fuel infrastructure, whether that's vehicles or homes, probably both, because they're connected these days, and air quality and health. We didn't quite get to that, but let's do that later.
Yeah. For listeners, this is indicative of me and Ian's conversation over the years, as we sit down to start talking about one thing and then end up spending 2 hours talking about something completely differently.
There's lots of interesting things going on in the world of air quality, Simon, so why would we not talk about them?
Yeah, no, indeed. So part 2 coming up. Iain, thanks so much for your time. I really appreciate you being so generous with it. Thank you.
Thanks. Bye, Simon.
Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know someone else who might be interested, please spread the word and let's keep building this community. This podcast was brought to you in partnership with 21 Degrees, Lindab, ACO, Ultra Protect, and Imbiot. All great companies who share the vision of the podcast and are not here by accident. Your support of them helps their support of this podcast. Do check them out in the links and at airqualitymatters.net.